My name is Jay Chandra Yadav Nalakimniyandi. My metric number is 20132957. Today I am talking about structure design to mini project. My first is steel beam, section type 406 time 140 time 53 UKB, all dimension based on section type according to table. Steel grade S 275, span length 7.5 meter, deposit depth 5.0 kilonewton per meter assumed. Permanent load is 2.5 kilonewton per meter assumed. Steps used to calculate steel beam human buckling resistance. First, find self weight of beam to calculate design load. Next, from the design load, get reaction force on both support to calculate shear force diagram and bending moment diagram. Next, find yield strength and section classification class 1. Next, find shear area to calculate shear resistance. Then calculate design check for shear using value of shear from shear resistance and shear force. Then okay, find moment resistance and design check for moment using value of shear from moment resistance and design moment. Then is okay. Next, calculate elastic buckling moment. Then using the value of shear to calculate non-dimensional slenderness or lateral torsional buckling. Next, determine the buckling parameter based on table 6.3 and 6.4 Euro to 3. Then calculate reduction factor for lateral torsional buckling. Next, finally calculate moment buckling resistance using value option from reduction factor for lateral torsional buckling. The section is satisfactory because maximum design moment is lesser than moment buckling resistance. Next, I talk about steel column. Section type 203 times 203 times 46 UKC, all dimension based on section type according to table. Steel grade has 275, column height 4.50 meter, load beam 10.08 kilonewton per meter. Steps used to calculate steel column lateral torsional backing system. First, find cross-section length including eccentricity and section length beam. Next, final external load from level 1 to ground floor. Find nominal movement at level 1 about y-axis and z-axis. Calculate district movement at level 1 about y-axis and z-axis. Calculate minimum buckling resistance which is column slenderness about y-axis and z-axis. Next, find column imperfection about y-axis and z-axis based on table 6.3 Euro code 3. Find reduction factor about y-axis and z-axis and take the laser value that consider that worst case scenario. Then calculate elastic critical moment and buckling parameter using table 6.5 and table 6.3 Euro code 3. Calculate lateral torsional buckling resistance and section resistance to calculate interaction equation. Interaction equation is resistance 1.0. Then interaction condition is satisfied. Next, steel connection, bolted column beam connection torsion. Ultimate load is 120 kilonewtons, diameter 24 millimeter, number of bolt is 10, Fu 430 Newton per millimeter square, holes E1 is 300 millimeter distance between center of holes, E1 50 millimeter, P1 100 millimeter due to 26 millimeter. Steps used to calculate steel connection. Find the direct shear. Next, calculate shear due torsion in bolt A. Next, calculate resultant shear FR in bolt A. Now let's try 24 millimeter bolt diameter. This diameter should be bigger by at least 1 mm at each side of the bolt surface. Next, calculate shear resistance and then compare it with resultant shear. Next, resistance capacity higher than resultant shear, it is good. Next, calculate bearing resistance. Finally, bearing resistance and then compare it resultant shear. Bearing capacity higher than resultant shear, it is good result. This is attachment and beam and column and steel. This is result. Thank you.
Good morning to Engineers. My name is Lee Chen-man. I'm being given a title of IR Doctor. My matric number is 201222960. This my title project is development of a single story building for mini market. My structural member is beam B/2 to 3. So this is a steel member design. I'm taking the section type of 406 multiple with 140 times 53 UKB. The steel grade will be S275. This is the data that I assuming. ULS combination, self-weight of the beam. We getting 0.523 km per meter, and for the GK we getting 3.023 km per m, and for the QK getting 2.5 km per m, and by using the formula 1.35 GK plus 1.5 QK, for the total design we're getting 0.83 km per m, and for the moment diagram we're getting 55.05 km by using the formula WD L square over 8, and for the shear force diagram we're getting 29.36 km by using the formula WD L over 2. Here will be based on the table 7 of EN 10025. TF we're getting 12.9 mm, and FY we're getting 275 Newton per millimeter square. The section classification we will lastly based on calculation we'll be getting 0.92, and outstanding French will be lastly we're getting an answer of 8.28, which is classified as class 1. The internal compression part will be 66.24. This is the final calculation, and getting is also classified as class 1. Next is a moment resistance. The moment resistance, finally, if we based on the calculation of equation, you're getting an answer of 0.194, which is less than 1 and considered as okay. The shear area, wet shear area, finally we're getting an answer of 3457.9 mm square, which is larger than 3008.3 mm square. There are two answers here. We were using a bigger value, so we taken 3457.9 mm square. Next is shear resistance. The shear resistance will based on the formula. Finally, we're getting an answer 549 kN. Next is shear buckling check. The shear buckling check will based on the formula 2. Finally, we're getting an answer of 66.2. There are no shear buckling verification required for this calculation. Finally, the design check. We will based on the formula like this, and we're getting a 0.05, which is less than 1.8, which is considered as section is satisfactory.
Finally, is for our moment buckling resistance. By using the formula, we're getting finally answer is 76.48 km, which is considered as section is satisfactory because it's larger than the MED, which is 55.05.
That's for my beam part. Next one is column B stretch weight, and for the column B stretch weight we cut 3 types of load.
Load beam is equal to 7.83 km per m.
Load beam 2 is 11.58 km per m, and load timber flow is 7.58 kN per meter square. And we just calculate as long as we need to find the exact the length and the extra load. And for the extra load part, for the timber joint is that we need to measure that the joint to be level, the thickness of timber wall of the column A need to be adjusted which is by 1 meter, so they can be level.
Finally, you're getting an AD equal to 192.02 km.
After that, we find the nominal moment at level 1.
For the M nominal Y, we're getting 5.68 km.
Z, we're getting 2.76 kN per m.
Distribute moment over Y-axis equal to 5.66 km.
And for the Z, we get 2.76 km. After that, we're finding the column standards for the fractional buckling, and we're getting the value of 0.718 for the Y-axis and for getting 1.235 for the Z-axis by base of formula. Then we go into the column perfection, and this all data we're getting from the table. And for the reduction factor, we will getting the value of 0.77 for Y-axis, and we're getting the 0.42 for the Z-axis. After that, we're finding the minimum buckling resistance.
For minimum buckling resistance, we're getting a value of 677.99 kN.
And for the MCR, we're getting 254.47 kN, and we're getting the lambda lateral torsional 0.733. We go into the buckling refractometer, and just like based on the table, we're getting that the alpha lateral torsional equal to 0.34, and just go for formula, and finally we're getting the X lateral torsional equal to 0.6765, and going to the MBRD, we're getting the 104.56 kN, and going to the section resistance, we're getting a value of 63.53 kN, and next we're going to the section resistance for the MYBRD, getting a value of 136.68 kN, and finally we're going to the interaction equation, we're getting a value of
0.3898
is satisfied. Since the interaction equation is satisfied, thus the section size of 203 times 203 times 0.6 UKC is okay, but not necessarily efficient. Returning to reduce to a smaller steel column section is challenging to provide details interpretation or significance of this value. That's all for the column part. Going to the subsequent timber flow work, and this is all the value we're going to assume, and this all data will get taken from the table, and finding the KM equal to 0.8 and the partial factor equal to 1.3, and for the case we're taking the smaller value and getting the 1.3, and then we're going to the final QK and GK, we're getting the FD equal to 7.58 kN per meter square.
For my design bending moment, I'm getting 0.134 kN,
and getting the design bending strength equal to 14.1 Newton per millimeter square.
For my WY, I'm getting 7.5 mm, and for my answer for the permanent load deformation, I'm getting the answer of 0.036 mm, which is the total deflection to the permanent action, and for the total deflection to the variable action, we're getting a 2.07 mm, and once it plus together, we're getting an answer of 2.12 mm, and this is the total deflection to the both permanent action and the variable action. And by comparing to the limiting ratio, we get an answer of 3.33 mm, which is larger than 2.12 mm, and is considered as okay. And the timber bonding is adequate with respect to deflection.
Good morning to Sir Dr. movies. My name is Pavindan Unlucky Picture number metric 201332043. Today I'm going to make a presentation video for my structure design 2 mini project. For my part, the steel beam that I calculate is 2/B2C. The section type that I suggested is 106 times 140 times 53 UKB. All dimension based on section type according to table. The steel grade is S275. The span length is 5.5 meter. Imposed load is 5.0 kN per meter as per assume, and permanent load is 2.5 kN per meter as per assume 2. Okay, this is the steps that I used to calculate steel beam moment buckling resistance. First, find self weight of beam to calculate design load. Then, from the design load, get direction force on both support to calculate shear force diagram and bending moment diagram. Then find yield strength and section classification. For my beam, the section classification is class 1. Then find shear area to calculate shear resistance. Then calculate design check for shear using value obtained from shear resistance and shear force. The result for my beam is okay, and same goes to the moment. The result is okay for my beam. Then calculate elastic buckling moment, and using the value obtained to calculate 9-dimensional standardness for lateral torsional buckling. After the calculation, determine the buckling parameter based on table 6.3 and 6.4, refer to Eurocode 3, then calculate reduction factor for lateral torsional buckling. Finally, calculate moment buckling resistance using value obtained from reduction factor for lateral torsional buckling. So overall, the section that I have suggested is satisfactory because maximum design moment is less than moment buckling resistance. Okay, for part steel column, for my part is C/2. The section type that I suggested is 203 times 203 times 46 UKC. Dimension, all the dimension based on the section type according to table. The steel grade is same as beam as 275. Column height is 5.5 meter. Load beam C/1 to 2 is 10.08 kN per meter. Same as load beam C/2 to 3 is 10.08 kN per meter 2, and load beam 2/B to C is 11.58 kN per meter. As calculated. The steps that used to calculate steel column lateral torsional buckling resistance is: firstly, find cross section length include eccentricity and section length beam. Second, find external load from level 1 to ground floor. Third, find nominal moment at level 1 about y axis and z axis. Fourth step is calculate distributed moment at level 1 about y axis and z axis. Fifth step is calculate minimum buckling resistance, which is column strengthness about y axis and z axis. Then find column imperfection about y axis and z axis based on table 6.1, refer to Eurocode 3. Then find reduction factor about y axis and z axis and take the lesser value to consider the worst case scenario. Then calculate elastic critical moment and buckling parameter using table 6.5 and table 6.3, refer to Eurocode 3 again. Then calculate lateral torsional buckling resistance and section resistance to calculate interaction equation. Interaction equation is less than 1.0, so it means the suggested section is okay. The interaction condition is satisfied. Then the timber joist. Okay, this is the last part for me in this mini project. Okay, which is timber joist, suspended timber floorboard. Okay, the service class is 2. The service class is identified by my team member who did the timber beam calculation. Then the K mode is 0.8, joist center to center is 500 mm, permanent action is 0.167 kN per meter, includes self weight, variable action is 2.5 kN per meter. Okay, the steps used to calculate section size for main joist timber is: firstly, find the design load using permanent action and variable action, then calculate design bending moment and design bending strength with assumed edge of 150 mm. Third step is find section properties using value obtained from design bending strength. Then calculate design shear force, design shear strength, and design shear stress. After the calculation, compare the design shear stress and design shear strength. For my calculation, the design shear stress is less than design shear strength, so the suggested the suggested size for main joist is okay. The joist is adequate with respect to shear. Then calculate design bearing force, design bearing strength, and contact length of bearing and design bearing stress. Using equation 6.3 from Eurocode 5, the section is adequate with respect to bearing. Then calculate lateral torsion stability using equation 6.33 from Eurocode 5 to check design strength. Okay, for my calculation, the design stress is more than design strength, so the result is not okay. So the suggested size for main joist is not okay, so it's recommended to increase the section size. Then calculate service ability limit state, which is deflection for permanent load and variable load. Lastly, calculate limiting ratio, then compare with total permanent load deformation and variable load deformation. So for the calculation, the limiting ratio is less than total of permanent load deformation and variable load deformation. So the section size that I suggested earlier is not okay. So it is recommended to increase the section size. And this is the attachment for beam, column, and timber joist for the deflection part, which means the last part. Thank you, sir. Until here is my presentation for my part from Structure Design 2 mini project. Thank you, sir.
Hi, my name is Amanda Zikri bin Ahmad Zamri. Today I want to present you about my part of structure design. Okay, for this part is I choose the column B, C for column 3 from section 3, which the length of the column is 5.5 meter, and then I choose the design of 457 times 4152 5 times 82, and then grade S275. The mass of column is 0.1 kilometer per meter, which is 82.1. Then I convert to kilometer per meter. Then I get the GK is 0.15 81 kilometer per meter. And then QK I get 3.0 kilometer per meter. And then 1.35 times UK, and then 1.5 times UK, and then I get a 5.5935 kilometer per meter. And then the reaction bearing moment and the shape force diagram, I get the B is 1.535, and then I get the A is 15 negative 15.382, which is the positive, the negative is the represent the direction of the shape force diagram. And then bending moment I get is the final bending moment is 23.26 kilometer per meter square. And then I get the reduction factor for LTB is the 1.1, and then the moment buckling resistance I get 547.52, which means that 23.26 kilometer per meter MED is lesser than 547.52, and then the sector is certified okay. The column I get the column is the height of column 7.5 meter. The beam load is F1 only, in Z direction 22.8 km per meter, and then added by load timber 7.58 km per meter, and then I choose the same column design T05 times T05 times 240, and then the analysis of the Thailand loads, which means that I get the cycle of the B column is 0.247 km per meter, and then the NED I get 30.627 km per meter after I add all of the load that I find that the previous result. And then the nominal moment and the level for horizontally is 5.15 km per meter, and then the MED I get the 5.15 km per meter, and then the intersection equation that I get from the this is 0.227 km per meter divided by 4 to 0.75 km per meter time, and sum of 1.5 times 5.15 divided by 536, and then I get the answer is 0.073 times 0.014, and then the final answer is 0.087, and then the answer is satisfied is okay because it's lesser than 1.0, and then the section that I choose 305 times 305 times 240, you can see is satisfied. Okay, that's all for me. Okay, thank you.